Hello, and welcome to the first tutorial out of the series of tutorials that we're going to be using in our Creative Tools course here in Sweden in Lund University. So before we begin, I will just start by showing you a quick intro of the desired output of this whole course. So basically what we're going to do is we're going to start working with let's say this kind of single module of curves, and we're going to relax them into this I would call it a pseudo triply periodic surface, because if you look at on the internet, if you just look at triply periodic surfaces and so on, these are always perfectly smooth in their connections, so there's no apparent seam in between these elements as you array them or tile them, while these ones might have slight discontinuities, so that's why basically I'm calling them pseudo triply periodic surfaces. You can just think of it as a module that's stackable in 3 directions. So that's the first thing that we're going to do. And then we're going to stack it, but we're going to not just stack it as an array. Let me just import this one real quick. We're not just going to stack it this way, but actually we're going to use what's called the Cellular Automata script, and we're going to replace the voxels with our triply periodic elements, right? So the output of that one should be something, oops, not there, renders something close to these, right? And I'll get into these kind of triply periodic surfaces, cellular automata, and so on as we go through the tutorials. But for now, this is the desired output of it and a scaled up version of it, right? And also, as a side effect, I guess, we will be using marching cubes algorithm to actually tie the cellular automata definition into a shape. So this is one of the examples. Something like this. I will be giving a short tutorial on V-Ray settings and material presets and so on in Rhino. But that will come in later, because the first focus is definitely on the definition itself, right? So that's about it for the introduction. I'll just start moving right into the creation of the definition itself, right? So the first thing that we need to do is we need to make this kind of a how do I call this, like a constructor out of curve segments for this element to work. So the way we're going to work with it, I'm just gonna move this to the side a little bit. First, I'm going to create a box, right? And I'm just going to say that it should start at 0. Oops. Again, box numblock on 0. And then I'll specify what's the size of my box, what's my desired size, right? So I'm going to say something like, let's go for 100 by 100 by 100, right? A box like this. So a box in itself, right? It's stackable, meaning that you can, if you just stack it this way, you can fill in the space. So it's a space filling shape. Anything that is inside of this bounding box and that is symmetrical and touching the size of the box should also by logic, be space filling. So we're going to treat it basically as a voxel for now. I'm going to select this box and I'm going to type silhouette to extract the outer edges of the box, and I'm going to lock them in place by typing in lock, enter, click on the box, delete it. Right. You don't really need to see this one for now. So we have this set up. So the next thing to do is to actually set up something, a module inside of this larger module that will be mirrored 1, 2, 3 times, right? To create this whole shape that's symmetrical in all axes, right? So the module itself should be 1/8 of this whole box, right? So it should be like 50 by 50 by 50. I'm going to create that. 50, enter, 50, enter, 50, enter, right? And make sure that you're starting your boxes at 0, 0, 0 coordinates, because that's kind of important. That's going to be important later on as we will start mirroring the shape around, right? I'm going to repeat the silhouette command, silhouette, enter, lock it in place again, select it, select the box, delete it, right? So I have these kind of two bounding boxes present. Next thing I'm going to do for now, I'm just going to create something very simple. Oh yeah, and also I would need to, I'll just unlock both of the boxes, select them, and I'll just place them into the default layer, right? So that I don't mess up my layers later on. Lock that back. So now in my, let's say layer 3, I'm just gonna call my layer 3 input rectangles. Right. I'm just going to create a few rectangles. Right. Let's say one here and 3-point rectangle from here to here to here. Right. For now, just these two. I don't really care about having them do anything fancy right now. For now, I'm just going to use them to check if the definition that I write works. Maybe creating a third rectangle would actually be a good idea as well. 3-point, like that. Because with 3 rectangles, you always end up working with data trees and lists and so on, while with 2 you can get away with just 2 separate inputs. So now as I have everything set up, and I'll explain, why we're creating these rectangles and so on as we move into Grasshopper. And we should move into Grasshopper, so I'm just going to type in Grasshopper. Wait for it to load up. Right. And I'm just going to select these 3 rectangles that I have. Make sure that everything else is locked in place. Select them and reference them in as curves. CRV, enter, right click, set multiple curves, and I have them referenced in, right? So now I'm working with these rectangles. Actually they can be twisted, right? This would work with something that's, for instance, if I had a rectangle like this, and I had some of the points lifted up like that, it would still work, right? And we will be using this option later on, but for now, just for testing, straight up rectangles are fine. So I have these 3 rectangles, and I want to make meshes out of them, because later on what we're going to do is we're going to use Kangaroo to relax those meshes into a minimal surface. So stuff from FryAuto and so on. So first things first, you could technically, there are two ways of how you can create a mesh from a bunch of rectangles, right? The first way is to get the discontinuities of each rectangle. So discontinuities means you get the corner points, basically the break points where the curvature of the lines breaks, right? So you get those 4 points per each rectangle. And if I were to check it with a panel, that's exactly what I get. 3 rectangles, 4 points on each rectangle, and I can construct a mesh from those points, right? By default, the phase instruction says that it should produce a quad out of first, second, third, and fourth point in every list. That's exactly what we have. So all we need to do is just plug in the points into the vertices input, and voila, 3 meshes, right? And then we can and those 3 meshes come in separate branches, right? If I were to grab the param viewer, I would see that, you know, this is the first mesh, second mesh, third mesh, created from first curve, second curve, third curve, right? So we kind of, to join them up, we need to have them in one branch and in one list, right? I'm just going to right click on the output and click on flatten, right? So now they are all in one list, and in a single branch. As I do that, I can join the meshes like that. And now if I were to check, I can see that I have a single mesh that has 3 faces, 1, 2, 3, and 12 vertices, right? The problem is that the resolution of this mesh right now, as I have it, is very low. It's actually 3 faces, so I need to increase it. The way to do it is to go to Beaverbird tab. If you don't have this plugin, you should definitely download it and install it. And I go to Subdivide, Catmull-Clark subdivision, or you can use Loop subdivision if you want to, but Catmull-Clark. Click here, disable preview of that, display, preview mesh edges on, right? So I'm subdividing the mesh. So each face of the mesh gets 4 polygons, right? So every polygon gets divided up into 4 polygons. So I end up with 12 polygons instead of 3, right? And I can kind of control it with levels of subdivision. If I were to choose to have 2 levels, you can see that the mesh gets finer, 3 levels, even finer, and 4 levels, suddenly we end up with a problem. And the problem is that it doesn't like it. It doesn't like it when you start setting it to level 4. A workaround this is to have level 3 and then copying the Catmull-Clark subdivision and then adding the level 3 again subdivision. And you can see that, you know, I end up with, let's hide this one. I end up with a really fine mesh in this way, with a really clean topology. So why we're doing it out of these like rectangular patches is because we care about the topology of the mesh quite a lot, right? So we're dealing with these rectangles. Another way would be just to create, you know, 3 surfaces and use the mesh command in Rhino to just mesh them, but this produces a much cleaner topology. And also we can kind of, let me just get rid of that one. This rounding, if you don't like this rounding, you can also kind of choose not to smooth the naked edges by typing in let's just do a slider between 0 and 2, right? And if I hover over this input, I can see that if I set it to 0, the edges will be fixed. If I set it to 1, they will be smooth. And if I set it to 2, only the corners will be fixed. And by default, it's set to 1, right? So if I were to plug in 0 here, you can see that it kind of smooths out this portion here, as it's subdividing the mesh, but it keeps the edges straight, right? So the biggest problem with this is the lack of control over how many polygons you have, right? You can either have a really low subdivision, or you can see it increases exponentially, because here you have 3 polygons, here you have 12. Then I'm bad at math, so let me just see the panel here. Here you have 48 polygons and 192, right? So you don't have a lot of control over the resolution of the mesh, right? What if you needed 120 polygons? You couldn't achieve that with this approach, right? So instead of this was just to show you, but instead of this approach, I would suggest doing it a different way. Let me just group this and disable this, that. So another way to do it would be to, we have these 4 corner points, and we're going to create a surface out of them. So if I go to Surface tab and I go to Freeform, here I can see the 4-point surface, right? The problem is that 4-point surface asks for 4 inputs, right? Point A, point B, point C, and point D, while here all of the points are, let's say, grouped in 3 separate lists, right? 4 points here, 4 points here, 4 points here. So what I need to extract point 0 from each list, point 1 from each list, point 2, and so on. To do that, I'll be using list item. List item, plug that one in here, right? So by default, list item, you can see here, it extracts an item from the list with index 0, right? So meaning the first item of each list. And here we have 3 lists, right? So we're getting the first point out of each list. If I need the second point, all I need to do is just click on zoom in here and click on the plus sign here, and that will give me list item index +1, right? And then +2 and +3. So this is the first item of each list, second item, third item, fourth item. And then all I need to do is just connect it straight up like so. You can see here I have 3 surfaces. Moving on, I need to change the surfaces into a mesh, into actually 3 meshes with a certain detail that I want, with a certain resolution control that I want, right? So to do that, I should first divide the surfaces, right, into series of points, a grid of points, and then I should create a mesh from points. Where is it? Utilities, mesh from points. This tool right here. So first things first, this node right here asks us to give it a grid of points, right? And here we only have surfaces. To get the grid, what I'm going to do is I'm going to divide the surface according to u and v values, right? Surface, divide, and by default the values are set to 10 by 10, but I'm just going to use like 11 or something like that. And make sure that you're using the same slider for both U and V count, because you don't want to care about the orientation of these surfaces, right? So you want these points along the seams to match up between the grids. Okay? So this way we have much more control over the resolution of the mesh. We will have much more control over the resolution of the mesh. So now these inputs here for the mesh, first one is the grid of points. I'm just going to plug the the grids here into the grid of points. Then it asks me how many points do I have in U direction and how many points do I have in V direction. And as I plug in these guys, the slider into U and V, you can see that it complains. It gives me an error. And it says insufficient number of points, right? So then I need to check what's wrong, right? I'm going to create a panel, and then I'm just going to check it with a panel. Then I see that for some reason my list of points ends at 13, right? The next list also 13, and so on. But what I want is I actually want all of these points, so 13 times 13, to be in a single list, right? So the way to work around it is, if I were to show you the data tree, right? The way to work around is to merge these outer data tree branches into a single branch here, right? These branches appear because the way Grasshopper works with grids is that it creates a branch for this set of points, right? Then for this set of points, for this set of points, and so on. So you end up with branch for each row of points. And we don't want that. We want all of those to be merged into one single list. A tool that does that is called trim tree. That one. And if I were to plug in my points here into the trim tree and grab a panel, plug that one in here, I can see that my list goes beyond 13 and actually stops at 195, right? Well, actually 196, because we start counting from 0. So I'll plug in those points here, the trimmed tree version of the point grid here. At this point, I'm just gonna hide some nodes. It's still complaining, and it's saying insufficient number of points still. Right, so what's the problem? Let's reduce the count to, let's say, 3, right? So what I have is I have something like this. And you can see that when I have the count set to 3, what it does, it actually produces 4 points for each side, right, of the rectangle. If I were to reduce it even more, 2, it gives me 3 points. That's because this is not the amount of points that you get. This is actually the amount of these separated patches that you get, right? So this is a patch, this is a patch, this is a patch, and this is a patch, right? So you always end up with 1 extra point, right? So this amount plus 1 in the grid, right? So all I need to do is I need to take this number and add 1 to it, right? 1. You can do it this way, right, with just straight up addition and a panel, or you can right click here and in the expression type in x plus 1. It's up to you. I'm just going to do it this way so that it's more clear, like that. Right, so now we have these 3 meshes and we have much finer control over the resolution, right, of these meshes. The thing that we lack is the ability. The thing that we lack in this approach is the ability to have this kind of rounded outer edge, right? So we don't have the ability to round off the outer edge, but that's fine. You know, in this case, it's something that it's okay to not to have, and we'll be able to incorporate it later on if we need to. So for now, we have 3 meshes, and what I'm going to do is I'm going to join them up. So first of all, even here you can see that they are in 3 separate branches, data branches. So I'm going to right click and flatten the data tree. So I end up with these 3 meshes in one single list. And I'm going to use join, mesh join tool. And then I'm going to make sure that it's a clean mesh. So I'm going to use unify mesh normals tool. So this just makes sure that all faces of the mesh are looking in the correct direction, right? So that you don't have one face looking this way, right, to the right, and one face looking to the left, right? So all of the faces are either looking inwards or outwards. Okay, so we have this set up. We should actually weld these seams as well. So the way I'm going to do it is I'm just going to use weld, mesh weld vertices. I think it comes with a within a plugin that's called Mesh Edit or Mesh Tools. I don't remember, but if you just in Google, if you just search for mesh weld vertices, you'll find the correct plugin that you need to have. Viewerbird's join meshes and weld also works. The weld mesh tool, for some reason, for me it sometimes misbehaves, but it should also work. I just like this, right? I prefer using this. So it asks us for 2 things. First one is mesh, and the second one is the tolerance, right? So the tolerance by default is set to 0.01, and that's fine. These vertices are basically on top of each other, right, in this seam where the meshes got joined. So this will definitely catch them. And I can check if it worked by checking how many vertices I have in the mesh before and how many vertices I have in the mesh after. And you can see that 50 vertices were deleted, were welded together, right? So this is the definition that we use to create meshes out of any set of rectangular curves. Just to make things clean, I'm going to create an empty mesh container here, like that. Mesh container here, that. Connect those two. This is just the way I work. Is I prefer to have you know, a large definition separated into smaller batches, smaller groups, and then I can just call it curves to mesh. So I'm just calling this group curves to mesh, and I know that, you know, I get my input is a curve, my output is a mesh. If later on for some reason I need to cluster this, you know, like that, then I can easily do it, right? Oh, it messed up quite a lot. Anyway, let me undo it. We don't need to cluster it. This is not going to be a very large definition, so there is no need to do that. So now we have our mesh here, and we need to relax it, right? So we need to make a minimal surface, a single minimal surface out of this, out of these three meshes. Well, actually now it's just a single mesh, right? The way we're gonna do it is by using Kangaroo, Kangaroo 2, and I guess Kangaroo is the only plugin with which I work backwards, right? So in Grasshopper I always work from left to right, right? So it's step by step, adding some methods or tools to existing geometry, while in Kangaroo I prefer to set everything up and then start plugging in things to where they need to be plugged in. Kangaroo always works with a solver, right? There are different kinds of solvers, but in this case we're just going to use the default one. So I'm just going to drop it in there, and it always has this kind of reset button and a toggle for on or off, right? So for the reset button, I'm just going to use a button like that, and for toggle, yeah, boolean toggle. And for now I'm going to leave it as set to false. So goal objects, well, threshold and tolerance, don't worry about those for now. Goal objects is basically a list of instructions on how Kangaroo solver, the physics solver, should behave, right? So the way we are going to work with it is I'm going to create a data tree, right? And each goal is going to be in a separate branch, right? So to create a data tree, we can use entwine tool, this guy. So everything that you input is going to be placed as a separate branch in the data tree, right? So I'm going to do this. And that means that the output here is going to be also a data tree, right? So I'm going to use explode tree here to only get the branches that I need, right? From the data tree. I can also use like a tree branch tool, but I prefer to have all of the outputs present for me. So now on to inputs, right? So this here, everything is set up for the simulation. So now for the inputs, right? So what kind of goals do we need for the simulation to actually run? So the first goal always that I use is called show, right? So what's the geometry that we're changing, right? And it's actually our mesh. So I'm going to go to main and I'm going to click on the show tool, right? Show node. That's our first goal, and that's our mesh that we're showing, right? So we're basically saying that this mesh, whoa, some fancy stuff going on there. Let me just try and recompute. Disable preview, enable preview here. Okay. Something's bugging out. I'm not sure what. We'll see if it messes with our definition later on. So basically, with this tool, we're saying that the mesh that we created should be simulated through and should be outputted here as our first branch, right? So our first branch is going to be a mesh, but it's going to be a new version of the mesh. It's going to be a relaxed version of the mesh, right? A minimal mesh. So for the second and third inputs, the way minimal surfaces are created is by having these kind of contraction forces within the surfaces, within the meshes, right? So if I go to goals mesh, I can specify that the edge lengths of the mesh, edge lengths, should try and become 0, right? So each of these edges, each of these lines should try and contract to have 0 length, right? So it's asking me for mesh, and it's asking me for length factor. So the mesh is this guy right here, and the length factor should be, let's just type in 0, right? So all of the edges are trying to contract to have 0 length. It also has strength, but we shouldn't care about it at this point. This is just how strong the influence of this particular goal is. Right, so we have this done. If I were to run the simulation now, let me reset and let me run it. You can see how it's just contracting to nothing, right? It's just contracting to 0. And that's because we're saying that it should, show the mesh, so it should change the mesh and it should contract, but there's nothing holding it in place. So of course, if each edge tries to become 0, the whole mesh is going to become a point, right? The way to fix it is by introducing anchor points and actually anchoring the mesh along its perimeter. Well, in this case, we're going to anchor it along its perimeter. If we go to goals point and click on anchor and place it here, I'll just plug it in there. This is gonna become red immediately and it's gonna complain, blah blah blah. It's because I don't have any anchors set up here, so it's freaking out. So basically what it's asking us to do, yikes, why is it? This is very strange. Well, that fixed it. Anyway, it's asking us for a list of points that we would like to anchor. So points of the mesh on the mesh that shouldn't move. What I want here is I want the outer perimeter points of the mesh. The way we can get them is by using naked vertices tool, which should be somewhere here. Under mesh, we have naked vertices. That we plug in the mesh here, and you can see that naked vertices actually gives us the clothed points, so that all of the interior ones, and the naked points, so only these guys. We can see them separately by just creating an empty point container, plugging in the naked points and highlighting it this way, right? So naked points are basically the ones that are not surrounded by polygons, while clothed points are the ones that are surrounded by polygons from all of the sides, right? I'll just plug it in like so, right? Target we don't care about because the points should stay in place, they shouldn't move, and the strength is 10,000 compared to the strength of 1 here, so it means that this is a very strong goal, right? And as it should be, right? Because we don't want the points to move, right? This is orange because here we have 3 branches as our inputs, and here as our output we only have 2 branches. If we just click on the plus sign here, you can see it fixes itself because suddenly we have 3 inputs here, 3 outputs here. It's okay with that. Let me disable preview of this one, reset just in case, and then run the simulation. And you can see here, this is precisely how a soap bubble would behave inside of this kind of frame. So this is a minimal surface, right? With a really clean topology. The way we're going to work with this tool, right? So let's see it like this. If I were to take, let's see this rectangle, and if I were to move it from here to here, right? You can see that this recalculates immediately, right? Like that. Or I could grab a point of this rectangle and just move it by, let's say, 50 units here, right? It doesn't care. It still calculates. In some cases, you kind of need to reset, especially if you're adding or removing a resolution. For instance, if I were to say, well, I actually want more resolution here, so I'm just going to increase it, right? You can see how this is starting to freak out. Oh, I can actually calculate it. Hooray. But if I were to add one more rectangle here, it wouldn't work that well. For now, I'm going to keep it at resolution, let's say 11, something like that. It seems okay. Just in case, I'm going to reset it to calculate. This is fine. Here you can kind of see that the shading is weird, right? And if I were to bake the mesh, let's bake it to default layer. Move it here. You can see that this is weird, right? It's shading it like that because here I have under display, I have color back faces on, right? I have this guy on, and then I have this color set to purple. Let's just do something more like that. So this means that after the simulation, the the mesh normals are not clean, right? The mesh normals are broken, meaning that these faces are looking, let's say it like so. These faces are looking towards the camera, while these ones are looking away from the camera. So we're kind of seeing the back face of these polygons. To fix that, all we need to do is in Grasshopper, we need to run this mesh through unify mesh normals. Sorry, mesh unify normals. And that should fix it. I sometimes prefer using, yeah, that fixed it. I sometimes prefer using the clean, the kangaroos mesh combine and clean tool. This one is also very useful. But if unify mesh normals works, then it's fine, because this is much faster computation wise, right? So now we need to fill in this whole box with this segment, right? And we don't just fill it in by copying, but we actually mirror it so that the whole large segment is well, it's not triply periodical, but it would be symmetrical in all three axes, meaning that if you copy it sideways, it would stack, right? Meaning that this edge right here would join up with the edge right here. To do that, all we need to do is start mirroring it. So we have this mesh here, and I'm going to use mirror tool. We are going to mirror this mesh. Oh, it's mirroring in that way. Let's fix it by specifying that the plane should be YZ, right? YZ plane of mirroring, and the origin should be, let's just construct a point. So the origin should be 50 units in X direction. 50. I will be reusing the panel 50, so I'm just going to place it here. Sometimes it does this, sometimes it shows it as a wireframe, but it's fine. Later on we're going to clean it up, so it's going to be a decent mesh. The preview is going to be fixed. Oh, it it fixed itself. Okay. So now we have this segment right here, and I'm going to join it into a single mesh. Right? So I'm just going to use mesh join tool, and holding down Shift key, I'm going to connect both of these, the original mesh and the mirrored mesh, into the mesh join, and I have like these two tiles here, right? So this is my joint geometry, and I'm going to repeat it, right? So there's going to be quite a lot of repetition going on. So now the thing that I'm mirroring is my joint mesh, and I'm going to mirror it again. This time the plane is XZ plane. Right. And let's just construct point, and the point where the plane is resting should be 50 units in Y direction, right? Like that. So we have this done, and we repeat the same thing. Mesh join, we join the original with the mirrored, holding down Shift key, like that, like that. And the last thing is mirroring it like again, mirror XY plane, so we're mirroring it upwards. Construct point. Oh, I'm just going to copy this one like that, and it should be mirrored in the mirroring plane should be 50 units in Z direction, right? So like that. And then we do the last mesh join between this guy and this guy. Mesh join. There is definitely a cleaner way to do this, but this is the most, straightforward, easiest to understand, and easiest to explain, easiest to showcase way. So I'm sticking to this. It's not too large, so it's fine. So we end up with a shape like this. It's kind of hard to see. Let me just create a custom preview, like that. Hide this here, change this to, let's go for Arctic mode, that. So this is our little mesh. If I were to relax it again, you can see how it relaxes. Okay. Shaded view. Okay. So now the thing is that, okay, the shape itself kind of works. There's a problem here. You should never ever have point-to-point connections. So I'm just going to move this guy back by 25 units. So we end up with this kind of a star-like shape, which is fine. The problem is that if you were to take this mesh, right, and if you were to move it sideways, or actually I'm just going to show it in Rhino. It's gonna be better this way. Default. If I were to move it here, zoom select all to zoom to it. This is not, you know, this cannot stack, right? If I were to copy it sideways by 100, these two guys, they don't connect, right? If I were to joint, it's gonna say that these two meshes were joined into one open, first of all open, second of all disjoint mesh, right? So there are two problems. The first one is that it's open, which is okay. The second one is that it's disjoint. And if I were to just select a clipping plane, create a clipping plane, and if I were to move it up, you can see here, this is a big problem. This makes it so that the meshes cannot be thickened in a way that they wouldn't intersect, right? So there's a lot of cleaning up to do with the initial curves, right? To make it actually work, right? And I'll leave it to you guys to actually figure out how these curves should work. I'll just show you an example. This one here that I've created. First of all, I just need to scale it up a little bit. Scale from here to here, we should have 100 like that. And instead of these curves, instead of this, this, and this, I'm going to copy in the white ones, right? So this one was a set of curves that I've already prepared for this tutorial. I'm just going to select these curves and copy them from here to here. Okay. Select them, go back to my Grasshopper definition, go back here, right click, set multiple curves. It immediately relaxes. Just in case, I'm going to reset the simulation just to make sure that it doesn't produce any errors, right? So I end up with something like this, which is kind of strange. There are some things that should be cleaned up. For instance, here we shouldn't see this kind of a broken shape, and that's because, okay, going back here, that's because what we do here is first we relax the shape itself. Let me hide this one. First we relax the shape itself, that, and then we start mirroring it, right? Like this. And that's a problem, because after we do this, we would require a secondary relaxation, right? To get rid of this nonsense, right? Because this is a sharp edge where it shouldn't be sharp. We can fix it by saying that, okay, the last mesh, the relaxed mesh, should be the final one, right? So what we need to do is actually we shouldn't mirror the mesh, right? The relaxed mesh, but we should mirror the curves themselves, right? these guys before we start playing around with meshing them. So the way I'm going to do it is I'm going to ungroup it, give me some space, move away the input curves, and all of the mirroring will be done here rather than afterwards, right? This should clean up the part where the curves are not, the mesh is not relaxing properly. Everything here is set up for the most part. So I'm going to, well, I don't need this one. I'm going to select this whole part here and move it back here to the to my curves tab. Not tab, but to where my input curves are. And then let's see what we need to change. Well, first of all, mesh join won't work, right? Because these are not meshes. Instead of mesh join, I'm just going to use group. And the way I'm going to do it is I'm going to say, okay, so my initial curves should be mirrored, right? So this is the first mirroring. They should be mirrored. This one immediately will start complaining because, you know, we mirror the curves and mesh join is asking for curves, and it is asking for a mesh and it's getting the curves, so it's freaking out. I'm just gonna delete it. So we have our curves and we're mirroring them, right? Like so. And I'm going to also group, just like we did with the meshes before. I'm going to group my curves, my initial curves, with the mirrored version of them, like that, right? So I have this group here, and I'm going to continue working with this group, right? So I'm going to take this group and mirror it again. Apologies. I'm going to mirror them again. And now what I have is I have this group and mirrored version of this group. So I'm going to group them again, like this. So all I'm doing is I'm replacing the mesh join with a group tool. Oops. Delete that one. And I have this one, mirror it again, right? And now, as the last point, I'm not going to group them because I will need to eventually ungroup the curves, right? So instead, what I'm going to do is I'm going to leave them separated, not grouped, but instead I'm going to use merge tool. I'm just going to place them in a same list, right? Merge. So what I have here, let's do a preview. What I have here, if I grab a panel, is I have two groups with two objects, right? In each group. If I were to use ungroup, like that, I would have 4 groups, so with 26 objects in each group, right? And if I were to ungroup that again, I will end up with separated referenced polyline curves, right? I'll just make sure that they are all in the same list by flattening the last output and plugging everything here into the discontinuities tab. And it seems like I've crashed my... Nope, I haven't. That's good. Yeah, before you do it, you should definitely reduce the UNV subdivisions, because this is exponentially harder for the computer to calculate. But we end up with something pretty nice, something like this. Okay, And now, this is too slow. Let me just 5, some low resolution. Okay, 5 units seems to be 5 division value seems to be okay. Just gonna relax it a bit more. That. So this is the geometry that we end up with. And what I'm going to do here is I'm going to say that this whole portion, let me just clean it up a little bit. This whole portion with the curve should be grouped. Let's make it a bit smaller. I can place it here. This one can be placed here. Just cleaning it up a little bit, like that. And I'm going to call this reference curves and mirror them 3 times, right? And this one is going to be called build mesh from rectangular curves. This one is going to be called relax mesh. Right? That's our final output right here. Okay. So this is done. And again, I've spent at least a few hours designing, you know, this particular array of curves. It's let me just see, 13. So in total here we have 13 segments. And the way to actually to check whether or not your array works is by producing something like move or is there an array? Let's just use move or array. Let's use array. That's a box array. I don't need a box array. Let's create a 3D grid. We can do that by going into vector grid. Well, we can do it with a square grid, I guess. Yeah, let's do it with a square grid. Base plane for grid, world XY, size of grid cells. So the size should be the size of our bounding box. Oh, I don't need this anymore. So it should be the size of our bounding box. So it should be 100, like that. EX, EY, and then we have our points. All right. I'm just going to flatten those out into a single list because I don't really need them to be in separate lists, right? So this way we created a planar grid, right? If you want to have more than one level, all you need to do is give it more than one plane, right? More than one XY plane. And for that you need more than one origin. So for that you need more than one constructor point. Construct point, like that. And I'm going to say that in the Z direction it should have series of numbers, right? Series of numbers, and the step size should be again 100, right? Because the height of our box is 100. So that's the step size. And the count should be, I don't know, well, the minimum you can have is 2, so let's do 2, right? So that's our count. And same thing goes for EX, EY. I'm just going to use the same number for all 3 of these, right? So this way I can kind of create this, I can kind of control this grid of points. For now, I'm just going to leave it at, let's say 3. Yeah, 3 is fine. And this is a static number, so it would be better to just type it in a panel, right? Rather than a slider, so that you don't accidentally make it smaller. So the last thing to do is to take this mesh, right? And move it from this 0, 0, 0 point to all of these points in this grid, right? So the way we can do it is, well, we'll need to move it. So move. What's the geometry that we're moving? So that's our mesh, this guy here. And we're going to move it from 0, 0, 0, right? So I'm just going to construct a point at 0, 0, 0 coordinates. So from this point to all of these points, right? So in Grasshopper you don't really have this kind of a move between 2 points tool. Well, you don't have a direct move between 2 points tool. Because the move command asks you for a translation vector. But what you can do is you can create a vector between this point, right, this guy right here, and all of these points by just doing a vector between 2 points, vector to pt. So my first point is the 0, 0, 0, 1, and my second point is the list of points here. And what I get is 48 vectors, right? The thing is that you don't really need the thing is that you can't really see the vector, right? So the vector itself is just a mathematical thing. It doesn't have a preview. If you want to actually preview it, you can by typing in vector display and selecting the 0, 0, 0 point as your anchor and vectors as your vector, and it's going to display, you know, the vectors that you've created. This is not important, but maybe it's visually easier for you to see how this particular thing behaves and how does it influence the move tool, right? So if I were to use these vectors as my moving, as my translation vectors, I get an array of these meshes, right? Which I can mesh join into a single mesh. Let me start hiding things so I don't need the vectors. This guy goes here, or something. Let's do something clean like this, right? Hide that, right? This is again, since this is semi-transparent, it's kind of hard to see what you're dealing with. So what I'm going to do is, first of all, I'm going to say the count should be like 1. Well, 1 is bad. Oh, actually, our math is messing up because here, since the count is 1, it's actually only, yeah, it's only counting the first number, right? So it's only taking in the 0 values. While here, since the count is 1, it's giving us 4 points, right? So we end up with 4 elements here. It's not a big deal, but what I'm going to do is I'm just going to right click on the count here, expression, and I'm going to say x plus 1, like that, so that these guys match up, right? Or actually, sorry, sorry about this, but it would be better to say not x plus 1 here, but rather x minus 1 for these two. That makes a bit more sense. X minus 1. Oh yeah, and it's gonna complain like crazy, but that's fine, because you can't have count 0 here, because 1 minus 1 is 0, right? So we start from 2, right? So we get this array of 2 by 2 by 2. So the way to actually work with this even more is, first of all, I'm going to create a custom preview so that it's easier to see what we're dealing with, right? And again, here you can see that these are actually triply periodic surfaces, like a gyroid surface and Schwarz-D surface and so on. As these guys tile, let's see the gyroid, right? There's no apparent seam, right? You can kind of see repetition, right, in this kind of geometry, but there's no apparent seam. While here the seam is very apparent, right? We can kind of mask it even further by saying that, okay, we have this kind of joined mesh. We need to weld it, right? So we need to weld all of the seams so that there are no duplicate points here. And I'm going to type in weld, mesh weld vertices, plug that one in, hide this one, see the preview of this, and you can see that suddenly it's all weird, right? That the shading is off. That's fine. That's fine for now. We will clean it up later on. So basically, after we arrayed the mesh, the elements, we joined them into one single mesh and we welded them. And what we're going to do next is we're going to smooth out these parts, right? So I'm going to type in smooth mesh, right? So what's the mesh that we're smoothing? It's our welded mesh. This guy here. Just going to click on preview here, like that, and then I'm going to see that the smoothing strength is 0.5. That's fine. 0.5 is okay. If you have the maximum smoothing strength, sometimes it starts complaining and making errors and opening up the mesh seams and so on. Would I like to skip naked edges? So basically, would I like to also smooth out these parts? I definitely wouldn't, right? So I am skipping the naked edges. I'm not smoothing those out. And how many iterations, right? That's the most important thing. And limit, we don't care about the limit. Don't worry about it. So iterations. This is iteration 1, right? Let me choose iteration 2. You can see it kind of moved a little bit between 1 and 2, right? 3, 4, 5, 6. And the thing is that the less iterations you have, the less, of course, this requires resources. The more iterations you have, the more resources it requires. It's basically when you're specifying that it should be 7 iterations, it's moving it 7 times, right? It's moving the mesh 7 times. So I'm going to say, I'm going to go for 20-ish, something like 20. maybe even more, 25. Yeah, that seems okay. So 25 iterations seems to do the trick. You can kind of see the bulge here a little bit, but this is way smoother than the original one, right? So we end up with something like this. And this is way closer to, you know, the gyroid or any kind of this kind of triply periodic surface that than this, right? This is still not a triply periodic surface. I wouldn't call it that way, but this is close enough to be called a pseudo triply periodic surface. So let's stick with that. Right. And the last thing to do with this is to actually see how this whole shape thickens, right? So and actually before I do that, imagine this. Here it's almost a second of calculation, right? To actually smooth out the mesh. Every time when you're going to run Kangaroo, when you're going to reset Kangaroo, it's going to calculate this whole thing, and it's going to smooth every iteration of Kangaroo simulation. It's going to smooth it 25 times, right? This is going to crash your computer. If you click on the reset button, it depends on the computer that you have, but it probably will crash your computer. So what I would suggest you do is you double click and create a data dam, right? And you should build this kind of data dam between the output of the Kangaroo, so here, and input of the move, right, which is here, like this. So as I did this, you can see that immediately everything here is gone. And that's because DataDam doesn't transfer information as long as you don't press the play button, right? If I were to press the play button, you can see mesh appears. If I were to reset the simulation, you can see it's well, you can't. Let me zoom out. There we go. Let's see here. If I were to reset the simulation, right, this is running, but this is not updating. This whole portion is not updating. And that's because the data dam, every time it gets a new set of information, right, here into its input, this kind of play button reappears, and it doesn't let the information through as long as you don't press the play button, right? So now when I press the play button, the mesh gets translated and so on. I guess a quick example wouldn't hurt. Data dam, panel, like this, like that. Okay, so let's say I have dog here in this panel, right? You can see that no data was collected on the other side of the data dam. If I press the play button, suddenly dog appears here, right? But if I were to change this to cat, here we still have the dog, but now the play button reappears, right? So now I need to press it again. This is a very strong thing to use when dealing with heavy definitions, because it makes it so that you don't break your computer, basically. It's a bottleneck, definitely, for in a good sense, for your definitions. So I'm just going to group this whole thing except the data dam and the custom preview. I'm going to group it. Move it sideways a bit. like that. And I'm going to call this array mesh and smooth out, right? And smooth out the mesh. Yeah, and that's basically it for this first tutorial. Later on, we're going to see how we can thicken this geometry, how it behaves with different thicknesses and different methods of thickening, and how can we actually make this 3D printable shape, right? That we will later on 3D print. But that's in later tutorials. So for now, thank you and goodbye.